Okay, you know the feeling. We've all been there. You're right in the middle of something important, a big deadline, a video call. Maybe you're just trying to stream your favorite show. And then, poof, everything just stops. The connection is gone. It's got to be one of the most common and, let's be honest, frustrating problems of modern life. So today, let's pull back the curtain and actually see what's going on behind the screen when your internet decides to take a vacation.
Ugh, that question. It can send you down a total rabbit hole, right? Unplugging routers, plugging them back in, making those frantic calls. The internet can feel like this mysterious black box. It just works until suddenly it doesn't. But what if I told you there's a logical way to understand it? A way to even diagnose the problem yourself? And this isn't just about us being annoyed at home. For businesses, the stakes are absolutely enormous. A survey from 2020 showed that for half of all businesses, network downtime costs them anywhere from $300,000 to a staggering $6 million. That's a massive hit to their revenue, to customer trust, and even to their data security. So yeah, keeping things connected isn't just a convenience, it's absolutely critical. So, how do the pros solve these super expensive mysteries? Well, they don't just guess. They have a secret map, a kind of conceptual framework that breaks down the entire, incredibly complex process of network communication into small, manageable pieces. And today, we're going to give you that map. This is it. It's called the Open Systems Interconnection Model, or OSI for short. Now, it was developed way back in 1984, but it's still the universal guide for understanding how data travels from an application on your computer all the way to an application on another computer somewhere else in the world. It divides the whole journey into 7 distinct layers, and each layer has a very specific job to do. Now, I know what you're thinking. 7 layers? That sounds kind of intimidating. But don't worry, network pros have this classic little trick to remember them. All people seem to need data processing. That stands for application, presentation, session, transport, network, data link, and physical. We're actually going to work our way up from the bottom, but this little phrase will help you keep them all straight. All right, let's put on our detective hats and start our investigation right at the scene of the crime. We're going to begin at the very bottom of this stack, Layer 1, and work our way up to see how your data makes its incredible journey across the internet. So, Layer 1. The first thing you need to know is that this is all about the hardware. This is the stuff you can actually touch, your Ethernet cables, fiber optics, even the radio waves your Wi-Fi uses. Its job is simple. Turn all that digital data into physical signals. So when your internet goes out, the very first question a tech will ask is a Layer 1 question. Is everything plugged in? Seriously, a frayed cable or a loose connection is a classic Layer 1 problem. Okay, moving up to Layer 2. Think of this layer like your neighborhood mail carrier. It's responsible for getting data from one device to another, but, and this is key, only on the same local network. It uses a unique physical address called a MAC address that's burned right into your device's network card. This makes sure that data gets to the right house on your street. A Layer 2 problem could be something as simple as your laptop not connecting to your home Wi-Fi because you typed the password wrong. But what if you need to send a letter to a different city? Well, that's where Layer 3, the network layer, comes in. This is where your router lives and breathes. It acts like a regional post office, using logical IP addresses to direct your data packets between totally different networks. This layer is what makes the internet an internetwork. So if you can connect to your Wi-Fi just fine but can't get to any websites, the problem might be at Layer 3. Your router can't find the path out to the wider world. And this brings us to our very first detective tool, the ping command. It's a super simple way to test if you have a connection at the network layer. It's kind of like sending a sonar pulse out into the network and just listening for an echo. You're basically shouting out to a server, hey, are you there? If you get a reply, you know you have a live connection at Layer 3. It's a fantastic first step. Okay, so your data has found its route. Now we get to Layer 4, the transport layer. This is basically the quality control department. Its job is to make sure the entire message arrives from start to finish, correctly and in the right order. It does this by breaking large files into smaller chunks called segments, and it can even resend any that get lost along the way. Now, Layer 4 has 2 main ways of getting the job done, TCP and UDP. Think of TCP like sending a registered letter. It's all about reliability. It needs a signature, it makes sure every single piece arrives, and it's confirmed. This is perfect for email or browsing a website. UDP, on the other hand, is like shouting a message across a crowded room. It's really fast, but you might miss a word or two. And that's totally fine for things like video streaming or online gaming, where a tiny glitch is way better than a long delay. All right, the top 3 layers: session, presentation, and application. We often just group these together as the software layers because they're the closest to you, the user. The session layer is kind of like a club bouncer, managing who gets to talk and for how long. The presentation layer is the translator, making sure both computers are speaking the same language and handling stuff like encryption. And finally, the application layer is the part you actually see and interact with, like your web browser or your email client. So how does all of this actually work together? Well, it's through a really cool process called encapsulation. Think about it like sending a package through a postal service. As your data travels down the OSI model, from layer 7 all the way to layer 1, each layer wraps the data in a new envelope with its own specific header and address information.
This visual shows it perfectly. Your initial data gets wrapped up by the transport layer, then that gets wrapped by the network layer, and finally, the data link layer adds its wrapper, all before it's converted into bits for transmission. Then, on the receiving end, the process just happens in reverse. It's called de-encapsulation, where each layer unwraps its own envelope to read the instructions inside. It's pretty elegant, right? And just to make our investigation a little more interesting, that package of data actually gets a different name at each of the lower layers. At the transport layer, it's a segment. The network layer calls it a packet. The data link layer sees it as a frame, and by the time it hits the physical cables, it's just a stream of bits. Knowing this lingo is a huge clue for more advanced troubleshooting. Now, the OSI model is an incredibly useful map. It's the perfect way to understand the concepts. But the internet that you and I use every single day, it actually runs on a slightly more streamlined, practical model. So let's see how our secret map relates to the real world. Here you go. On the left, you've got our 7-layer OSI model. And on the right, the 4-layer TCP/IP model, which is what the modern internet actually runs on. You can see it's a more condensed version. It combines those top 3 OSI layers into a single application layer, and it combines the bottom 2 into a network access layer. The important parts, transport and network, are still there doing their jobs. So our map still works. It just has a few less rows. So there you have it. You have the map and you understand the core concepts. Now you're ready to become the network detective. So let's put together a practical toolkit that helps you go from being a frustrated user to an empowered problem solver. The real key takeaway here is that troubleshooting isn't just random clicking and hoping. It's a methodical process. You start by identifying the problem and figuring out its scope. You talk to other people who might be affected. You implement a fix, and this is so important. You document what happened so you can analyze it and maybe even prevent it from happening again. It's a clear, actionable plan that turns you from a victim of the problem into the person who solves it. So the OSI model, it reveals this beautiful, logical structure that's hidden inside what feels like the chaos of the internet. It transforms a really frustrating problem into a puzzle that can actually be solved. And it kind of makes you wonder, right? What other complex systems do we rely on every single day without ever seeing the elegant order that actually makes them all possible?
Thanks for watching. Like, share, and subscribe.